We're going to write the polar equation in rectangular form, starting with this polar equation. The first step that we want to do is to put this polar equation in standard form, which means we want a leading one here. So I'm going to divide this term, and this term by 0.2 so that we have standard form. So now that I have standard form, I can start to look at the eccentricity and the directrix for this polar equation. The eccentricity should be the absolute value of the coefficient of the trig part of this. And since we don't see anything there, that means we have a positive 1. So E is going to be positive 1. We really want that absolute value of whatever that term is. And the directrix is E times D in the numerator, so if E is 1, then D has to be 4.8, since 1 times 4.8 is 4.8. So the directrix, or the D value up here is 4.8, and since this is sine, we have this going in the y direction, so this is the equation y equals 4.8 for the directrix. Okay. At this point, we can start to look at a sketch of this and look at finding the vertex. Looking at the form of the equation, since we have sine here, we know that this is going to either open up as a smiley face or down as a frown face. The eccentricity of 1 tells us we're dealing with a parabola, so it's either a smiley face or a frown face. It's positive here, which interestingly turns out to have this frowny face here. We can start looking at the vertex for this. Since the vertex should occur straight up from the pole, we know we've rotated from the polar axis this direction, so we've rotated pi halves in this direction to get to this vertex. So the angle of rotation here is pi halves, and then the vertex, we want the distance between the pole here and the curve, and that distance we don't know directly, but we do know that out beyond this curve is the directrix going through 4.8 out here somewhere. And the directrix and the pole here are separated by 4.8, and this curve has to lie halfway in between the pole and the directrix. So if we take 4.8 and divide it by 2, we are going to have the value here, or this R value between the pole and the curve. So the R value for our vertex is going to be 4.8 divided by 2. So this is going to form the point for the vertex, and then you can simplify that. Alright, so we are trying to go from polar form to rectangular form, so we want to convert this vertex point into a rectangular point. So off to the side here, I have some notes of important things that we need to know. I have the distance formula here for polar distance, but we haven't really used it yet. We've been able to kind of do a workaround without using this formula, but you certainly could have tried to use this formula in finding distances. I have a rectangular equation here for a parabola, and I have some notes about p-values. We will get to that. The p-value is the distance between the focus and the vertex, which we already found to be 2.4 here when we divide this out. And then down here I have my conversion from polar points to rectangular points. If we have an r and a theta here in polar form, then we can plug it into this and simplify to get our rectangular point. So that's the next step that we're going to do, is we're going to switch this point into rectangular point. So 4.8 divided by 2 is 2.4, so I'm going to have 2.4 cosine of pi halves. and then 2.4 sine of pi halves. And this will be the vertex in rectangular form. So the rectangular vertex, when we simplify this, we're going to get cosine of pi halves is 0. 0 times 2.4 is 0. Sine of pi halves is 1. 1 times 2.4 is 2.4. So this is our rectangular vertex. Alright, so this is important because the h and k in this parabola formula and rectangular form is this point right here. This is the h and this is the k for this formula. So now we also have to have a p-value, but I said we already know the p-value because p, and let me write this down, p is distance. It's between the focus and vertex. And if you really wanted to verify that we already know this value, you could plug values into the distance formula and calculate this. And you're going to find that it's 2.4, the distance between this point and this point. So our p-value is 2.4. And notice that p-value, if it's less than 0, is a frowny face, and p-value, if it's larger than 0, is a smiley face. Now some of you may question, if this is a distance, how do we get a negative value? Well, that's a good question if you've asked that. Notice that in the distance formula here, we're taking the square root, and typically when we're doing algebra, we take the square root, we get a positive and a negative value. Typically when we do geometry, we throw away those negative values because you shouldn't be able to have a negative distance. This is one place where we can actually make a use of a negative value. So this should be plus or minus 2.4 if you plug everything into here. And in this case with the parabola, to get the transformation from polar to rectangular, we need to keep the negative value if we have the frowny face version of the parabola, and we keep the positive value if we have the smiley face version. So since we sketch this and our parabola looks like this, we're going to make our p-value down here negative. Alright, so when we write this out, we need to have a negative p-value, so that when we plug it into this formula over here, we actually get the correct formula in rectangular form. Once you can get past that idea, we are almost done here. We're just going to start plugging in values into this formula and simplify, and we will have our rectangular equation. So x stays x. The h is coming from this rectangular vertex point. We're squaring that. We're going to have 4 times the negative p here. Y stays y, it's our dependent variable. K is coming from this point also. And now we start to simplify. So x minus 0 is x, and then square that, we have x squared on this side. And now we need to start multiplying through here. We're going to have 4 times negative 2.4 is negative 9.6. And then we're going to take that negative 9.6 and distribute it through to here. So we'll have negative 9.6y plus 23.04. Alright, and now we want to solve this for y, because that's typically how we do things for rectangular. We have it y equals something. That's the explicit form. So we want to move from the implicit equation here to the explicit equation. So I'm going to subtract the 23.04 from both sides, and now I'm going to divide both sides by the negative 9.6. And I'm going to switch sides here so that I have y on my left-hand side, so that's pretty much the standard form we typically use. So I'm going to have a negative 1 over 9.6 x squared plus 2.4. And this is our final answer. If you use a graphing program, you should be able to graph our original polar equation and our new rectangular equation, and you should see that they are the exact same parabola. Cheerful calculations.